Hello, my name is April, and in this video, I will be discussing my submission of the M4 classification challenge. The focus of this project wasn't only on building an accurate classification model, but also on integrating principles of responsible AI, ethics, and explainability. These are essential elements in any AI project today, as they ensure the solutions we build are fair, transparent, and accountable. The project began with a through a thorough examination of the dataset. One major issue I identified earlier was class imbalance, which can introduce significant bias in predictions. To address this, I applied SMOTE, or you can call it synthetic minority oversampling technique, which generates synthetic examples of minority class to help balance the dataset. By doing so, I ensure the model would not be biased towards the majority class, which is critical for fairness. I also took care in the processing phase by handling missing values with imputation and standardizing the data, maintaining data integrity and ensure a reliable foundation for the models. There was no personal or sensitive data involved, but I still made sure to apply its ethical data handling practice throughout the project. For model training, I experimented with several algorithms, including random forest, XGBoost, and LightGBM, and used by PyCaret to automate and streamline comparisons. However, rather than focusing solely on performance metrics like accuracy, I used a stratified k-fold cross-validation to ensure consistent evaluation across all data segments. To evaluate the model comprehensively, I looked at precision, recall, F1 score, and ROC and AUC, providing a balanced view of performance. Especially important for imbalanced data sets. This approach ties back to the responsible AI principle of fairness, ensuring the model performance well across different metrics and doesn't unfairly disadvantage a particular class. Explainability was another key priority in my project. I integrate both shape and line to provide transparency into how models make decisions. Shape values offered a global perspective, showing which feature has the most influence across all predictions, while line provide local explanations, breaking down individual prediction to show why the model arrived at a specific decision. The combination of global and local explanation makes the model more transparent and truthworthy, which is vital when AI systems are used in sensitive or high-stake scenarios. Accountability was also maintained through clear documentation. I tracked each step of the workflow from data preprocessing to model selection and tuning, ensuring that every decision was justified and reproducible. This transparent process makes it easier to audit the model's development and hold system accountable. Another core aspect of responsible AI. In terms of future work, I see several opportunities to enhance projects alignment with our responsible AI principles. For example, I like to implement fairness audits using more advanced fairness metrics like disparate impact and equal opportunity difference. I also plan to explore counterfactual explanation to give user actionable insight into how different input might affect predictions. Additionally, introducing human in the loop feedback mechanism could allow for better oversight and help correct model behavior over time. Lastly, I believe setting up continuous monitoring for data drift and model degradation would ensure the system remain fair and reliable long after deployment. To conclude, this project goes beyond building an effective machine learning model. It demonstrates a commitment to responsible AI by embedding fairness, transparency, expand, explainability, and accountability into entire workflow. As AI becomes more deeply integrated into critical decision-making process, applying these principles isn't just good practice, it's essential. And thank you for watching, and I look forward to any feedback or question you might have.